Okay, chapter 14 is us calculating either Ka or Kb, depending on whether it's an acid or a base, from percent ionization. So this is just the exact opposite of chapter 13. All right, again, you would only calculate Ka or a Kb of a weak substance, so most likely we're going to have a weak substance in here. So it looks like we've got 0.1 molar acetic acid, okay? So the major species. Ooh, what the heck? Okay, acetic acid. All right, weak acid. What do weak acids do? They go to equilibrium. They lose a hydrogen and form the conjugate. Okay. So again, all we have in there is a weak acid. So if we're going to calculate Ka or Kb, we have to know all of these guys. We have to know the acetic acid, we have to know the hydrogen ion, and we have to know the acetate ion, because we'll set up the equilibrium expression, Ka, and it's not given because that's what we're solving for, equals products over reactants, oops, excuse me, over reactants raised to their coefficients, which are all ones. Oh my goodness. Okay, so in order to do this, I have to know all three of these species to calculate Ka. So the extra piece of info I was given in here was how much of the acid had dissociated and or ionized. How much of it became this and how much of it became this. That's what this is telling you. So before I go any further, of the 0.1 molar acetic acid, 8.1%, which is 0.081, ionized. So if you calculate that out, that is 0.0081 molar of it is hydrogen, and 0.0081 molar of it is acetate. So what does the ice chart look like? Well, let me rewrite out the expression. So acetic acid in equilibrium with its ions, ICE. The initial concentration of this is 0.1 molar. You don't have any of this, and you don't have any of this. However, we don't need to let X equal anything. Why? Because they gave us this piece of information. We know what these two guys are at equilibrium because they told us how much it was allowed to break apart. So at equilibrium, the hydrogen ion is 0.0081 molar. And since these are in a 1-to-1 ratio, this is also 0.0081 molar. So I must have gained 0.0081 molar, 0.0081 molar. Now, this is a 1-to-1 ratio between hydrogen and acetic acid, so I must have lost, remember reactants lose, 0.0081 there. So 0.1 minus 0.0081, I got 0.0919. So look, I have all equilibrium values. There's no x's in them or anything. So now I solve by plugging back into my equilibrium expression. Ka equals 0.0081 times 0.0081, which is the same as 0.0081 squared, right? All over 0.0919. So you set that up, 0.0081 squared divided by 0.0919. And I'm getting, let's see, 2 sig figs, right? Because that 8.1%, 7.1 times 10 to the negative fourth is my Ka for acetic acid. Now, I need to be honest with you. Sometimes, actually fairly often, this bottom number, remember we always assume X is really, really small. So sometimes you will see people put 0.1 down at the bottom, the initial concentration. They won't subtract the tiny amount because remember we always pretend it's small. I will accept both ways. If you want to plug 0.1 in, which is the true concentration from the beginning, that's fine. I'm doing it the true appropriate way. If you gained that much here, you lost that much here. So truly it's close to 0.1, but it's slightly less than 0.1. So I did it as 0.0919. Again, I will accept both answers, and I'm fairly confident that the AP test will as well. So that is it for chapter 14.